Hello everyone, welcome back to Nated Engineering once again. We are still on stress and strain, and today we are looking at an exercise. The exercise reads as follows. Figure 1.23 and the figure that they are talking about we are given below. Shows a trussed collar on a shaft. The allowable shear stress for the shaft material is 60 megapascal. Calculate, those are the questions. Question number 1. The safe thrust load that can be applied to the thrust bearing. Question number 2. The compressive stress in the shaft. Question number 3. The pressure between the collar and the housing. This is the structure that they are giving to us. We are having a force of P that is applied on this shaft. This is a bearing. You can see this is a bearing. So we are having the shaft diameter, we're given the shaft diameter as 90, and then we're given the thickness of this collar as 12 millimeters, and we're given the diameter of the collar is 110. So if you're looking for the top view of this thing, it will look something like this, with this being the shaft. So what happened here is it's like we were having a collar with a hole and a shaft, where we took the shaft, inserted it in here, and welded the shaft in this hole, so that we're having this thing as one material. So if you can ask for a cross-sectional area of this thing, it will look something like this, with this being the shaft that it's welded to the collar. So let's look at the question. They say, question number 1, calculate the safe thrust load that can be applied to the thrust bearing. They are looking for force P, the force that can be applied, the safe thrust load that can be applied here. So remember, they gave us this, and they said it's the allowable shear stress for the shaft material, and then it's given to us as 60 megapascal. It's a shear stress, remember that. So we know shear stress is given by force divided by area. So we have the stress, we are looking for the force. We need to get the area that we are going to use here. Looking at this diagram, if this material is going to shear, where will it shear as a result of this force being applied in the direction that it is applied on? Remember, we are having a collar like this, and there is a shaft that is inserted, it's welded to that collar. This collar is balanced, so that if the force that we are applying is large enough, these two will separate here, meaning it will shear in this position, in such a way that the shaft will now be on its own, and the collar will be something like this, with this one being a hole. So if this thing is to shear, this is where it is going to shear. So we have to get this area, which is the area that we are going to put here. So let's do it like this. We know that the shaft, it's circle. Sorry about that. Through a circle like this. Yes. The shaft is of a circular nature, and there is a thickness from this point to this point. So our area will be given by pi d. Pi d, we are looking for, it's like we are tearing this object here and we are stretching it like this. This length will be pi d. And then We are looking for the thickness because we know area is given by length times breadth. Our thickness is given to us as 12, meaning our area is given by pi d times thickness. That will be our area. So to calculate for the force that it's needed, that the force P, the safe force that can be applied to this material, we are going to say stress is equals to force times area. We make the first subject of the formula. We are going to put the stress is 60 times 10 to the power 6 times our area, which is pi. Diameter of the shaft is 0.09. What is the thickness? 0.012. And this will give us a force of 203.58 kilonewton. That is our question number 1. And then we go to question number 2. They say the compressive stress in the shaft. So I forgot to point out something. We remember to always check, since here we were dealing with shear stress, the area that we use, notice that it is parallel to the force that it's applied. Now on question number 2, they are ask for what? For a compressive stress. Compressive stress is caused by a compressive force, which is a type of what? Direct stress. And we know that direct stress is caused by a force that is applied directly on the cross-sectional area that we are working with, or the force is acting perpendicular to the area that we are working with. So what we are going to do is we are going to say stress is given by force divided by area. The force we already have. We just calculated it, as a matter of fact. It is 203.58 times 10 to the power 3, which is force P. And then the area that we are dealing with is the area of the shaft, since they are looking for the compressive stress in the shaft. We're going to say the area is pi divided by 4 times the diameter of the shaft, which is 0.09 squared. And this will give us a stress of 32 megapascal. And then that is our question number 2. We go to question number 3. They say the pressure between the collar and the housing. Now they are looking for the pressure that, let me change the color. They are looking for the pressure that will occur here. Not taking into consideration this hole, because this section, the housing and the collar, they are not in contact. We are only dealing with this area. Remember, the SI unit for pressure is Pascal. The SI unit for stress, it's also Pascal. So we are going to use the formula to calculate stress to get the pressure that they are asking us to calculate for. We're going to say stress is given by force divided by area. The force is still the force, which is force P. There's only one force that is applied on this material. We are dealing with, we want to get the area. Which area are we going to use? Looking at the force that is applied, it's applied going down. We are looking for the pressure that will occur here. We are going to deal with the area where the housing and the collar are in contact. Remember, the collar, it's something like this, and it has a hole where we are going to find the shaft. But this section, the housing and the collar are not in contact. around on in this section. So the area that we are going to deal with, it's going to be area of this circular, which would be pi divided by 4. The diameter of the collar is 0. times 0.11 squared, and we have to minus the area of this small circle. So I'm going to do it like this. Since we are going to have pi divided by 4 being common, I'm going to minus here the small diameter, which is 0.09 squared. And that will be the area that we are going to use. So let's just put this everything into one formula and calculate for the pressure that they are asking us to calculate. Area, stress rather, is given by the force divided by the area. The force that we're dealing with, we already calculated the force, which is force P, and got that it was 20358 times 10 to the power 3 divided by the area that we're dealing with, which will be pi divided by 4 in bracket will be 0.11 squared minus 0.09 squared. And this will give us the pressure between the housing and the collar as 64.802 mega Pascal, and that is exactly what they are asking us to calculate, which will be the conclusion of our video today. I will see you on the next one.